Okay, so for this part of differentiation, I'm going to introduce about the parametric differentiation. All right, I'm going to explain in this video. I'm going to explain what is meant by parametric differentiation here. So as you see that the x and y are not related directly. They are not related directly. So they are related by using the third variable. This is the third variable. Means x and y is not related directly. So now, so this t, the third variable, we name it to be a parameter. All right, parameter. So this is they relate. They are not directly related. So but if I want to eliminate the t and relate x and y directly, that also can, okay? So we can write, we can modify such that the t square here, you have t cube. So I go and square for this part here. I go and cube for this part. So I cube. So I was getting x cubed equals to t to the power of 6. All right, for this one, I want to make it become t power of 6 so that I can relate y and x. So I can make it become t to the power of 3. I go and power of 2. Both sides I power of 2. So that the t will become power of 6. Y to the power of 2. Now you can see that t power of 6 and t power of 6. T power of 6 is x cubed. T power of 6 is y squared. So I can say that the x cubed and is equals to y squared. This one is called relate directly. X and y relate directly. For this type of, this is implicit, right? Implicit function, right? Implicit function where x and y are relate directly. But for this, the x relate to t, y relate to t. They are not relate directly. This one is called parametric equation. The x and y that are in term of t, we name it to be parametric equation. So the way of differentiate a parametric equation is by using parametric differentiation. And the way of differentiate this one directly without the t is called implicit differentiation, right? We can say implicit, we can use implicit differentiation, right? So I'm going to show you in this video. This video is the introduction about parametric equation. So for example, if I have x cubed equals to y squared, right? As you know that we can differentiate this with respect to x, or I can rewrite as y squared equals to x cubed. I'm going to differentiate this whole thing with respect to x. So means that differentiate y squared, I will have 2y dy dx. Differentiate x cubed, I have 3x to the power of 2. So therefore my dy dx is the same as 3x to the power of 2, right? 3x to the power of 2 divided by 2y. So this is a dy dx that in term of x and y. So let's say I'm going to using parametric equation, means that x equals to t squared, y equals to t cubed. So this one is indirectly, all right? But actually you can relate these two by modify something here, then you can get the relation between x and y. So this is a third variable, which is a parameter. So now let's say I want to differentiate this. I can differentiate this as dx dt. So I know that differentiate parametric x in terms of t, so I differentiate, so I'm getting 2t, and dy dx, dy dt, right? dy dt, so you're getting 3t squared. So if you have dy dx, so I'm going to using chain rule now, the chain rule. So which is dy dt multiply with dt dx, right? This is the parameter, right? It's a parameter. So it means that we relate the y and x to parameter. So this is the dt dx here, which will cancel off, right? So what is your dy dt? So your dy dt is 3t squared, right? 3t squared multiplied with dt dx. Dx dt, right? Dx dt. So dt dx. So terbalik, right? So 2t will become 1 over 2t, right? So you are getting 3t squared over t. You have 3t over 2. right? The dy dx for this case is 3t over 2 in term of t, right? And this one is in term of x and y, means that the dy dx is related by using t. This one x and y. So, but you can still modify this one because you know that x square, right? As you know that x square is t to the power of 2 to the power of 2, right? If x square, t also square. So t square square again, right? So over with 2. So what is y? Y is t cubed. Y is t cubed. So then you have 3 t square and square, you have t to the power of 4 over with 2t cubed. So if you reduce this thing, you are getting 3 over 2 t, right? T4 over t cubed. Can you see that? The result will be the same, right? The result will be the same. So this is I solving this problem by using implicit differentiation, right? By using implicit differentiation. And I solving the same problem by using the t, right? I use the t to relate x and y, but I using the chain rule. Okay, then I getting doing parametric differentiation. This is parametric differentiation. This is implicit differentiation, right? So it's the same, all right? Either you want to relate, most sciences, they need a parameter to relate x and y so that they can see x relate to y or y relate to t. Okay, so for example, time, t can be time, right? So as this application is using in the parametric differentiation is using in the problem of relate to rate of change in physics, in science phenomena, or the modeling problems. Okay, so for this video, I'm going to introduce you. Actually, parametric differentiation is another type of differentiation that differentiate a parametric equation. So hope you understand. In the next video, I'm going to teach you how to calculate, how to do parametric differentiation. Alright, so thank you.